The objective here is to explain why and how functions can make code easier to read and maintain. So in this lesson, students learn to define and call procedures in JavaScript. Procedures are called functions in order to create and give a name to a group of commands for easy and repeated use in their code. Okay, so we'll start off with some reflection. I'm going to go ahead and read these questions, and all you have to do is choose one of them to reflect on from day 4's lesson. So the first question asks, what surprised you about programming with such a small set of basic commands? Were you able to be creative with such a limited set of tools? What was most frustrating about this activity? If you could add one additional simple command, what would it be and why? So your answers may be you were frustrated because you had to repeat some commands so many times, or that you wanted more power to do things more quickly. You may also have mentioned that you wanted a right turn command and commands to take more than one step at a time, or commands to create simple shapes such as squares. Well, with programming, the power of programming, you can definitely create these scenarios where you don't have to repeat your code. So right here it says learning to program isn't just a matter of memorizing commands. The art of programming is always about understanding how to use the features of a programming language to solve a problem. So at the very least, we can expect that the machine's behavior is repeatable, so we can run some tests until we understand what the computer is doing and why. So then the challenge and fun of programming at its core is understanding how to use and combine those machine instructions to make the computer do what you want or to solve a problem. So think right share here, what other examples in life can you think of that require you to combine things into a solution? Go ahead and pause here if you can answer this without any help. However, if you need help, my first thought was a truck. There's many working pieces that are combined to make a truck run smoothly. And I don't even know how all the pieces work, but usually when one of them breaks, I learn about what made that piece work and then fix it, either by replacing it or fixing it in some other way. So we're sort of walking into a new definition for abstraction for you here. I'm writing that abstraction is pulling out specific differences to make one solution work for multiple problems. And so my video today won't be very long because I'd like to watch this one with you guys.
One of the most important concepts in computer science is how to define new commands, how to add your own words to a computer language. Most computer languages have only about 100 words or commands, and really the art and magic is in defining your own new words out of these building blocks. We do this all the time in sports. For example, in basketball, you start by learning how to dribble, how to do a layup, how to rebound. Once you've learned these really basic moves, you learn new moves and put together these building blocks, like a pick and roll or a give and go. And you can then go from there to do more complex plays. And once you learn that play and give it a name, everybody on the team knows how to do it. Similarly, once you've taught a computer how to do an action once using these sequence of commands, you can make up your own name for that action, so it's easy to repeat it later. When you define your own command and give it a name, that's called a function.
There are 2 steps to using functions in JavaScript. First, we need to define our function, and then we need to call it. When you define a new function, you are simply giving a single name to a set of actions you want the computer to perform. To call a function, you just type the name of the function followed by parentheses. This is actually telling the computer to perform or execute the set of actions you gave a name to. You've already been calling functions when you use the turtle commands. The only difference is that someone else defined them for you. Notice in AppLab, the toolbox now has a tab called Functions. There are 2 blocks in there, one for defining a new function and one for calling a function. Let's make a function that moves the turtle forward twice. We'll call it Move Twice. Drag a new function block out and type in the name you want to give the function. Now, add the code that you want to run when the function is called. We'll add 2 move forward commands and then run our program. Hey, we defined a function, but nothing happened. The reason is we forgot step 2. We need to call the function. To call the function, we drag out the other block in the Functions tab and add in the name of our function. Now that we have both defined and called our function, the code will actually run and the turtle will move. Notice that if I also call the function before its definition, it still works. It just calls the function twice. Defining a function simply gives a name to a block of code without actually running it. The definition can actually be anywhere in your program. The rest of the code will execute line by line, just as before. Calling a function executes the lines of code inside the function, and afterwards, the program returns to where it left off when the function call was made. The fact that the function definition can be placed anywhere means that your code can get messy and really hard to read. So we typically put our function definitions at the end of our programs to help keep things organized. In JavaScript, we call them functions, but the generic term is procedure. All programming languages have a way to define and use new procedures, and it's just another example of how computer scientists use abstraction to solve problems. Once you've written a procedure or function that you know works as intended, you can call the function as often as you wish without worrying about the details or problems you had to solve to get it working. And in defining a function to perform a certain task, you've essentially increased the capabilities of the programming language and can now use that function on its own or as a part of even more complex actions. You can also see why it's important to give your function a meaningful and descriptive name. If you called it something like do stuff, it would be unclear what the function was supposed to do and make it hard to use in your own code. By referencing a large and complex block of code by a single name, it makes it much easier to understand what a program is doing by reading the code, and also easier to locate and fix problems or errors.
Okay, so I'm no professional programmer, but I'm pretty sure she was incorrect when she said she puts the definitions of the functions at the bottom of the code. It's been my experience that those are in the top, but it's not a big deal. It really doesn't matter where you put it because the program will still run, but like she mentioned, your code can get big and complex really quickly, and so thus the need for a new definition of abstraction. We want abstraction to be pulling out specific differences to make one solution work for multiple problems. So some reasons for programmers to create functions, and I want you to, of these 4 reasons, pick one that you think is the most powerful. So the first one is it enables programmers to write code in larger, more logical chunks. Second one says programmers can focus on what something does rather than how it does it. So just creating a function and having all those little lines of commands inside there and then putting it somewhere else so you don't have to stare at that anymore. This really helps in your programming flow, in your creation of a program, okay? The third one is it streamlines code into shorter but more readable sequences. So I think that one is very similar to the second point. It just makes code easier to understand. And the last one is that it enables programmers to reuse code segments. So this is what we're looking at in terms of blocky code. It's not my favorite. I'd rather just go with the text, especially since you're high school students, so I'm preparing you to be adults. But you know what? If this is where we got to start, then that's where we got to start. So speaking of start, so using these blocks, we can drag and drop things together and then click and add names and numbers to the code to change it. What do you think a block of code like this could be used for? So at this point, I want you to jump onto this studio.code.org website for the puzzle. Okay, so there are 7 challenges, and take your time, do your best on that. When you're ready to make the leap, especially with the text instead of the blocky code, when you're done doing the code.org, you can jump onto sololearn.com and begin that JavaScript modules. Because as far as today is concerned, this is it. Your DOL, write the 2 items, and it says 2. That's going to be a tricky thing to remember when taking the AP test. But the test has questions where you need to bubble in 2 answers. So write the 2 items that are true statements about functions. And I want you to write them out, not just put ABC. I don't even have ABC here. I want you to write it out because if it's true, writing it is a good form of a note for you. So that's the first question. And the second one here is, in your own words, explain at least one reason why programming languages have functions.